So our speaker is Suni, and she works at the Armed Forces DNA Identification Laboratory, and she's been a part of the mission to identify missing U.S. service members for almost 25 years. She recently earned her PhD in forensic genetics, and she was part of the team that worked on the DNA testing of the Romanov remains located in 2007. So we are excited to have her here, and I'll hand it over to her, and we'll get started.
Thank you and welcome everybody. Thank you for coming today. I really appreciate it. So as Kate said, my name's Suni Edson. I am Assistant Technical Leader at the Armed Forces DNA Identification Laboratory. I have been working there for 25 years, and so I'm here today to tell you a little bit about our testing, our DNA testing of the Romanovs, as well as just a little bit about who we are. So one thing today, I tried to make this a little bit of a mix of different situations. So it'll be a little bit of history, a little bit of science, and then probably a little bit of both. So with the outline today, I'm going to give you just a brief introduction of AFDIL and who we are, as well as the history of the event. So I realize that a lot of people probably already know everything about the history of this event, but just for those of you who don't, I really wanted to give just a little bit of a background. And then the DNA testing basics, the original DNA testing, the identification of Anna Anderson, which is relevant to this whole idea of DNA and family ties, and then what happened next and how DNA testing changed. And so how DNA testing changed, that second part is the part that I was involved in. And then a postscript of what is still there and what has happened. So I wanted to give you an introduction of who we are, just because I feel like that gives you an idea of why we took on this testing. We are a division of the Armed Forces Medical Examiner System, and we were established in 1990. And from the start, we had the ability to do a great deal of DNA testing. Our specialty is skeletonized remains. But we're a mission partner with the Defense POW MIA accounting agency that works to identify the remains of missing U.S. service members around the world. But frequently, we have the capability to do historical remains. And that is where we came in with the idea of the Romanovs. This is our specialty. Most laboratories don't have the capability to do identifications of skeletonized remains, and we are one of the labs in the world that has that ability to do not only the identification process, but we're an accredited laboratory, which is very important if you have situations where you might need to go to court in the future. So this is an introduction to the teams of people who were involved. On the left, you have, of course, our AFDIL team. All of these individuals were involved in either or both of the identification processes. Ms. Barrett Ross and Mr. Mark Wadhams were involved in both. The University of Strathclyde is Dr. Peter Gill. We also have individuals from Austria and Russia, Dr. Pavel Ivanov, and then the team from Austria. And then numerous other scientists help to combine their work and their technologies to confirm the results that we acquired. So I'm going to move on to the history of the event, which I realize a lot of you might actually already know, but like I said, if for those of you who don't, I wanted to show some of the information and why it turned out the way that it did. Now, we all know that this is the Russian royal family, the Romanovs, with the Tsar Nicholas in the center and the Tsarina Alexandra, and then their daughters arrayed around them, with Anastasia on the far right and Alexei, the Tsarevich, kneeling in front of his mother. Now, this is important for the identification process and where they wound up. So when we get into the historical situation, you're going to see part of the history in genetics is that the Tsarina was part of the royal families of Europe and was the granddaughter of the Queen Victoria of England. And this is relevant to the identification process later on. Victoria was a carrier of hemophilia, and this is pretty prevalent within most of the royal families of Europe as they tended to interbreed. And Victoria's daughter Beatrice was also a carrier for hemophilia, introducing it into the Spanish royal line. Now, Alexandra, the Tsarina, transferred the gene to her son Alexei, who was, of course, quite notably a hemophiliac. Now, hemophilia in and of itself would have been largely untreatable at the beginning of the 20th century. And Alexei was frequently ill. He hemorrhaged often and was bedridden. And as the only male child of the family, the Tsarina and the Tsar were desperate for a cure. And while Rasputin was not directly involved in their deaths, it was his influence trying to heal Alexei. Or to be clear, he wasn't trying to heal Alexei. He wormed his way into the family as a spiritualist, and he promised them that he would cure Alexei. And in the obsession that the Tsarina had with healing her son or making him better, they kept Rasputin close, which was relevant to the fact that this in turn eventually isolated them from both their families and the Russian people. Rasputin's influence helped to restructure the Duma and the Synod and alienated both of their families, leaving them largely alone in 1917 when the Bolshevik Revolution occurred and the Tsar abdicated his throne. Now, in 1918, the whole family was taken into custody. Well, they were already in custody, but they were taken and imprisoned at the Ipatiev house in Ekaterinburg. And joining them there were their family doctor, Dr. Bodkin, Alexei Trump, the valet, Anna Demidova, the maid to the Tsarina, and Ivan Karatanov, the family cook. And these were the only servants that they were allowed. They had been stripped of all of their other family members and their other servants. And while they were in captivity for 78 days, the family tended to increase personal ties with those around them. Individuals who were set to guard them, they actually really enjoyed being around them. The Tsar was very charming. The girls were, fun. They read. Everyone liked each other. And they were able to get notes out to family members and take notes in. And it was probably not what was intended when the Bolsheviks imprisoned them. And indeed, when they found out that they were having these personal relationships with individuals, they replaced the entire staff. And so on the night of July 17th, 1918, the entire family was taken into the basement and murdered. The Czech army was close to the border of Ekaterinburg and close to being able to get into the city to rescue them. But other than that, there had been very few attempts to get them out, and thinking, of course, that no one was actually going to kill the Tsar and the family. But Lenin and the Bolsheviks decided that they were too dangerous to be kept alive, so they murdered all of them, along with the 4 servants and the Tsarina's dog. Now, this picture, which I realize is frequently shown, is always kind of dramatic. You see it and it's quite damaging. However, many of those holes were put in the wall based on the attempt to find evidence for the murder. And I won't go into the details of the murder, as that is kind of unnecessary at this point, but suffice it to say that everyone in that room, the family, the 4 daughters, Alexei, the Tsar Tsarina, and the 4 servants were killed that day. And the chief executioner, Mr. Yurovsky, took the bodies into a truck along with several of his henchmen and set out with the intent to bury everyone at the Four Brothers mine. Now, they couldn't get the bodies into the mine because the ice had frozen over the top of it. The intent was to put them in there and let them sink. Well, since they couldn't get them in there, they transported them to another location and burned the bodies and buried them the next day. Now, for whatever reason, Alexei and his sister were buried separately. Now, of course, this wasn't actually known until later during the excavation. So the red circle up at the top is where the remains were eventually transported and buried by Yurovsky. And for 8 years, the government denied that the Romanov family had been killed. And this just fueled speculation that they had escaped or were still being held captive. And in 1926, Stalin allowed for a publication of a document that said that the entire family had been, of course, murdered in 1918, but no grave was presented and no proof was presented that they were dead. There was a beginning investigation in 1919, 1920 to be able to find it, but however, the lead investigator at the time died and no further work was done. Now, in 1979, a geologist and filmmaker named Dr. Alexander Avdonin discovered the location of the presumptive grave, yet he was in fear for his life at having found this. Take in mind, this was communist Russia still at the time, and he and his wife feared for their safety should they release that information. And so he kept it secret until 1991, after kind of the feeling of glasnost and the ability to not be under communist rule. So the picture on the right was taken by Dr. Koebel when he met Dr. Avdonin in 2007, shortly after the discovery of the grave. Now, what they found in the grave was that there were 9 individuals present. So 9 of them were recovered, and there was anthropological analysis done by both American and English UK scientists. And they discovered that, of course, that there were only 9 people there and that the Tsarevich was missing, along with one of his sisters. And this is where DNA officially comes into the process. So we're going to take a pivot here. Instead of talking about the history, we're now going to talk about DNA. So I'm going to give you a little bit of a primer about DNA and how it's used in the identification process, or how it was used at the time, and some of the things, and later we'll talk about more about what we currently do. Now, in the 1990s, DNA technology was very much at its infancy. We had really only started in the mid to late 1980s with being able to use it at all. Of course, we knew of its existence, but to be able to use it as a statistically significant way to identify anybody, the 1990s, this was brand new. Skeletal remains are particularly challenging. They still are considered one of the hardest media from which to recover DNA. And primarily what was done at the time, and what the lab of AFDIL was formed for, was we used what was known as mitochondrial DNA. Now, mitochondria are these little, everybody always says, okay, well, the powerhouses of the cell. So mitochondria are these little organelles in your cell that generate power. So if you hear of somebody having a mitochondrial disease, it's usually they have low energy and an inability to process energy in their body. But when we talk about DNA on your, crime shows, or in general, even in genetic genealogy, primarily we're talking about nuclear DNA. Now, while we had the capability to test nuclear DNA, it was not thought to be feasible for testing of skeletal remains. Mitochondrial DNA is present in thousands and thousands of copies in your cells, while nuclear DNA is only found in one copy in every cell. And you'll note here on the left that I do mention Y chromosome DNA, which is a subset of nuclear DNA. And when we did the original testing in the mid-90s, testing Y chromosome DNA was not possible. Ys are very small. They're hard to test until more recently, when we had kits designed specifically to test that. Now, mitochondrial DNA, where we're looking, is at this very small piece of the mitochondrial DNA. To back up for a moment, mitochondrial DNA is circular. And when we're testing a region, we're only testing this little snippet of it. And our target for degraded remains is approximately 650 base pairs. And it's great. It gives us a lot of information. We can differentiate individuals with it. However, it is what is known as a lineage marker. It passes down through your maternal line. So you and your siblings all have the same mitochondrial DNA if you all have the same mother, but your brother's children will have his spouse's mitochondrial DNA. So it's not unique to women. It simply passes through the maternal line. When we build our databases, that gives us the opportunity to determine uniqueness and whether or not things are consistent. But as I said, we have thousands of copies in each cell in your body. So if we're looking at even a tiny bit of physical matter from you, we should be able to generate a mitochondrial DNA profile. Now, as I said, mitochondrial DNA is a maternal lineage, so anyone in green in this picture is related maternally to each other and the person in red in the center. And so it's a great tool. It's a great tool for historical analysis and for anyone where you're trying to identify somebody where you will not have immediate relatives available. And so when we're processing samples, we take bone samples into the laboratory and they're returned to us from the anthropologists or from whoever is recovering from the field. And sometimes this is police officers. Typically, samples are nominated by an anthropologist and they just remove a small sample of the bone for testing. And typically, what they send us is only about 2 grams to 5 grams. And now we can work with much smaller fragments, but at the time of this is what we worked with. And so we very carefully have to clean them. We work under conditions that are very sterile. And then on the right over here, you see the inside of a tooth. Because what we do with the teeth is try to be able to section them out and drill out the relevant material and then reassemble the tooth so that it can go back to a family member. And this was the same case here. We were trying not to destroy any of the material. Because once you get it clean, it does get pulverized and then it gets dissolved into the DNA. And then we don't want to destroy the whole thing. Part of the problem with DNA testing is that it is destructive. You're not going to be able to give anything back to the family in most instances. So mitochondrial DNA, once you take apart that 650 base pair fragment and stretch it out, we use what are called these overlapping primers or overlapping it literally is like priming the pump, if you've ever primed a pump, and it gets things started. So it sits down and it reads that fragment and makes thousands and thousands of overlapping copies. And then we assemble those copies to give us a read and to give us a profile that's compared against a known sequence. And then it looks like this. So once you sequence it, it determines the order of bases. And so we use software to read the order of the bases and to tell us what the person's profile is as compared to a known sequence or a reference sequence. So when we are sitting here trying to determine if someone is consistent with each other, if you look at the person all the way on the left with the unknown sample, and if that is what we're saying is their profile, and the positions are simply there to give you that's what we would determine, that's what it looks like to have a profile. And you compare it to each of these people and say, okay, well, it's not related to the next person because the profile is not the same, but it is related to these other 2 people who are marked in green. So you may have maternal relatives out there that you don't even know that you have. And mitochondrial DNA is great for reassociation. When you have a set of commingled remains, you can start testing those pieces and go, oh, I have at least one person here or multiple people. So when you have 9 presumed individuals, you can sort them by mitochondrial DNA. Unless, of course, you get into situations where you have a lot of the same family members, which is the problem with the Romanovs, or not the problem, but one of the issues with our process. Now I'm going to mention this part because we do talk about this a little bit in the first testing, but this is more relevant to the next testing. Autosomal STRs is what we talk about. Typically, when they're talking about it on TV or in crime shows, we're talking about autosomal STRs. This requires a standardized kit. It is very straightforward. You take your extracted DNA and you put it in a kit, but it doesn't always work well with degraded DNA because what we're looking for is large fragments. And it also requires relatively closely related family members or a reference from the missing person. One of the things that people don't talk about a lot when you are talking about identification projects is that you can't identify someone if you don't have a reference. You can say, well, I generated a DNA profile. Why can't you say it's them? Well, because I don't have a reference for them. I don't know, I don't have a piece of DNA from them before they died, or I don't have something from one of their family members. And that just makes it, I cannot prove that it's them. I have their genetic material, but nothing to compare it to. So primarily the people in brown are the spouse and the children of the missing person. Green are the parents and siblings, which are also great. And then as the further you get out, the more difficult it is, but you can actually generate a probability of identification with a large number of individuals at far reaching, as long as you have a number of them. So say 5 or 6 nieces and nephews or cousins would be great for generating a statistic. And also YSTR testing. YSTR testing also requires a standard kit. And like mitochondrial DNA, it is also a lineage marker. However, it traces the paternal line through men. Women don't have a Y chromosome. Therefore, the only people you're going to be able to reassociate with this are males, which is very important in the future for the identification. So we use standard kits, and this is just a picture of some of the standard kits that we use. And like I said, DNA testing strategy requires a comparison to a family reference. So in a historical and missing persons cases, a lot of times you're not going to have a family reference for your target person. So for the DNA testing of the first exhumation, what became readily apparent right at the beginning is that there was a difference in conclusions between the two different groups of anthropologists. The Russian, Dr. Abramov, had said everyone's there except Alexei and Maria. And Dr. Maples from the US team had said it was Alexei and Anastasia. So then the problem would be, okay, well, how do we prove who's there? So then they decided to do DNA testing. And this was probably rather revolutionary at the time, since there wasn't a lot of DNA testing going on at this point in history. So Dr. Peter Gill at the FSS in the UK did the initial testing and generated a limited autosomal profile from the remains. Now, this in and of itself, again, is quite shocking, as this was very new. This is a 5 locus profile. Now we do 23 as a standard. And the reason we thought this probably worked is because the remains were in a very cold ground and permafrost, therefore it preserved the DNA. But then when you're trying to reassociate everyone, so as anthropologically, we knew who the children were and probably made an assumption about who there were only 4 adult males in the grave. And so we were trying to be able to decide who the czar was. And so when we did mitochondrial DNA analysis on the czar, this came up. It's called a point heteroplasmy. It's this piece with the blue over the red at this one position. And since DNA testing was in its infancy at this time, this was really questioned. It was whether or not this was a mixture or a true result. And so when we got a reference from his great-grandniece, Xenia, and I realize I have spelled it differently on the slide in 2 different ways, she doesn't have that position. She's got a clean red peak. So then the question is, was it real? And this still to this day causes a big discussion. But the Tsar Nicholas's brother, Georgy, who died in the late 1890s of pneumonia, was exhumed. We saw the same pattern in him. So can you say that they are probably related to each other? And it was agreed that they probably were. And when we actually examined the entire line, it was not unusual to have the Tsar and his brother have one way. And the Duke of Fife was also related to the Tsar and his brother, and along with Xenia, who was the reference originally, both had a T, which is the red, and Georgie and the Tsar both had a C over a T, or a T and C position. Though this is what's called a point heteroplasmy, and this is not unusual, as we know now, when there is becoming a mutation within the mitochondrial DNA and things are shifting. So you will see that one or the other will be inherited throughout the family line, and it will slowly transition to another type, which is what we see. It probably, in Louise of Hesse-Kassel at the top, was a C, or the blue peak, and then it slowly transitioned down to a T in the rest of the family line. And we know now that that's not particularly unusual. So this is our general family tree of everyone we had. When testing the remains that were in the grave originally with the 3 young women who were there, it was easy to associate them as children of the Tsarina. So there were only 2 adult women in the grave. And by process of elimination, you say, well, you have an adult woman who shares a mitochondrial DNA haplotype with these 3 children, therefore this is a Tsarina and the children. And she was related, as we know, related to the English royal family, and in testing Prince Philip, the Duke of Edinburgh, showed the same mitochondrial DNA profile. So we believed we had the Tsarina, we believed we have Tsar Nicholas, but we're still missing those 2 children. Now, this goes into rest of whether or not this was actually a doubt of identification. This was a doubt over whether or not the family had died. It doesn't matter that the DNA process that we did seemed like it showed we have a mother, a father, and their 3 children and 4 other adults. That doesn't matter because there's still all of these stories out there. The DNA testing was in such an infancy at that point that it was hard to know whether or not everything that we had generated was correct. We knew we were correct because we were very sure in our science, but there was so much doubt from whether or not the family had actually died in 1918, and it led to the romantic notion that Anastasia and Alexei were still alive, particularly the fact that they were both missing from the original grave. And so when in doubt came all the pretenders. Now, even when I was working on this slide, I don't realize that how many pretenders there were. Not only was it Anastasia, but there were more for Maria, 53 different claimants. But one of the most famous was Anna Anderson. And she lived as Anastasia from the early 1920s until her death in 1984. So why did this come up now? She first appeared in Berlin in 1920. She was pulled out of a canal in Berlin, was very ill, but was recognized as a Grand Duchess, or particularly Anastasia, while she was living in a mental institution. And over years, she went from institution to institution, and she lived as Anastasia, but called herself Anna Anderson, but acted as if she was Anastasia and was treated as one of the Grand Duchesses. So when the first grave was located, and it reignited this whole idea that Anastasia and Alexei were still alive, and that maybe Anna Anderson really was Anastasia. We certainly didn't find any of the remains. So her husband offered a tissue biopsy, and it was accepted for mitochondrial DNA testing, and it was sent to our lab. We did the testing and showed that she didn't share mitochondrial DNA with Alexandra or any of the other children who were there. And despite the fact that Anastasia or Maria and Alexei were missing from the grave, Anna Anderson was not Anastasia. Most likely, Anna was a woman named Franziska Szankowska, who was a Polish housekeeper. And so because this was actually known at the time that this is who she was suspected to be, they were able to test the mitochondrial DNA of a grandson of her sister and show that more than likely that this is who that person was. And it is not assumed that she really did the charade on purpose, but she did suffer from a mental illness and simply came to believe that's who she was. And even though we did test the intestinal biopsy, her husband and her supporters severely believed that she still was Anastasia and provided additional samples to us to test. And so hair was later tested in the mid-90s and also confirmed to have the same mitochondrial DNA profile as the intestinal biopsy sample. So what happened next? Well, what happened next was that in 2007, the second grave was located about 70 meters from the original grave by a group of amateur archaeologists. The second grave was located literally steps away from where they were originally buried. And much to everybody's excitement, it was disinterred and they performed an official excavation by the local archaeological institute. And they found 44 bone fragments and teeth and believed through the bone samples that they had found that there were at least 2 persons present. And when I say bone fragments, I don't mean fragments. It just means partial skeletal elements. Because through anthropological analysis, they were able to determine that 1 person was female and 1 person was male, approximately 12 to 15 years old. And so, because they realized that this was going to be of such concern, the Russian government invited teams of 2 different laboratories to provide testing on the remains. Us, AFDIL in Maryland, and also the Institute for Legal Medicine in Austria. And so this is part of the testing that I participated in. And so we weren't only just asked to test the newly recovered remains, but to retest the old remains. And could we improve upon the results that we generated in the 1990s? So here's how testing had changed. Mitochondrial DNA testing had been greatly improved. This is what we started with. And now we've added in all of these other testing strategies and able to pull it out. Take in mind, this is 2007. Nobody did SNP testing yet. We didn't do SNP testing. We didn't do next generation sequencing. This is all manual. None of this is automated. This is all by hand, and we can work in these smaller and smaller fragments in order to get the entire control region covered. And our fundamental chemistry of how we extracted DNA samples had also changed. It resulted in a huge reduction of the amount of bone necessary. We don't need 2 grams of bone anymore. We can use 0.25 grams of bone in order to get a result. And we had over a 90% success rate for almost any element in the body tested for mitochondrial DNA. And then also too, for YSTR testing, we now had what is called a low copy number or a low template strategy and a standardized kit. So we could use YSTR testing to see if the males in the grave were related to each other. This would allow us to confirm the results that had been generated first of assuming that that person with that point heteroplasmy and mitochondria really was the czar. And so with all these improvements, could we identify the children? Well, we couldn't put names to them because we don't have references for them, and there's 5 of them. We could definitively say whether or not they were siblings to each other and the children of 2 people within that grave, and know who those 2 people are. So initially we did autosomal DNA testing on the 2 new sets of remains and determined that 1 set was male and 1 set was female. So we were able to confirm that because a lot of times when people are younger, as one of the sets of remains was 12 to 15 years old, it is easy to see that that could have been female. So now we've confirmed it with DNA. We had a boy and a girl. And so since we knew Alexandra's mitochondrial DNA sequence, because we knew she was related to Prince Philip, we were able to confirm what that mitochondrial DNA profile was. And we were able to say, yes, for sure, this adult female skeleton in the grave is maternally related to the 5 children within the grave. So our results were consistent. They were consistent with the original testing, and they were consistent with testing done in Austria and the UK. Now, since we knew which of the young individuals was male, we were able to do YSTR testing. And using a low template technique, we were able to generate a full YSTR profile, and which is fantastic, as we didn't anticipate even remains that we work on today from more recent conflicts. We often don't get such a nice profile because a lot of times they're subjected to other insults. So the fact that this almost 100-year-old sample worked this well was quite remarkable to us. We were also compared it to the adult male skeletons in the grave and found that, okay, well, this unknown male is consistent with Nicholas and Wise. And if you look at the family and trace it down, you do have this modern relative, Andrew Andreevich, who is also consistent. And so we know that that is really Nicholas, and that unknown male is most likely Alexei. So we went on to calculate additional autosomal testing. And in doing the autosomal profiles for the two unknown skeletons in the grave, we were able to calculate an autosomal likelihood ratio of 5.63 million that these two individuals are siblings. And so that gave us a statistical calculation that these two individuals are most likely siblings to each other at really quite fantastic probability. And in doing autosomal testing on all of the individuals in the grave, and then being able to say that these 5 children are siblings to each other, and the children of these 2 adult individuals is a likelihood of 4.36 trillion. So we know that they're a family unit. We've combined the data from all of the other samples, excluded the other 4 individuals in the grave as being related to these skeletons, and be able to say that for all evidence together, that this is indeed Nicholas, Alexandra, and their children, Olga, Tatiana, Maria, Anastasia, and Alexei. Now, unfortunately, as I said, we can't separate out the daughters. We don't know which is which. The girls were very close in age to each other, making it difficult to separate them out into individuals. I mean, we were able to separate them out individuals. We just weren't able to give them a name. So at present, what remains from this? What has happened? Well, in 2000, even prior to the finding of the second grave, the Russian Orthodox Church canonized the Tsar and his immediate family. And they're officially designated as passion bearers and not martyrs. The reason is that they were murdered, but they weren't murdered for their faith. They were designated as kind, generous people, and that bears the notation of passion bearer and not martyr, though often they're referred to as martyrs by people in the church. In 2016, the Bishops' Council of the Russian Orthodox Church also named Dr. Bodkin, who was their family physician, as a passion bearer. I'm not entirely sure why the other individuals in the grave were not named passion bearers, but that may come about later. In 1977, the House of Special Purpose, the AFDIL House, was declared as no historical significance and destroyed. But currently, on their site, there is a cathedral. The Russian Orthodox Church, the Church on Blood in Honor of All Saints, resplendent in the Russian land, now stands on the former site of the Patiev House. And on the right here, you can see a statue that is made to the royal family. That is Nicholas in the center holding Alexei in his arms. And at the burial site itself, where the remains were discovered, is also a place to go on pilgrimage. This is the Ganina Yama, the Monastery of the Holy Passion Bearers, and it is located at the former gravesite. I know I feel like that ended rather abruptly. You know, it's a huge amount of history, and there's so much that goes into this, and there's so many discussions that go on still about whether or not the Romanovs themselves have actually been identified. There are still questions that come up. A lot of people, you know, as one of the people who worked on this, I am certain that they have been identified and that these individuals that we located are the Russian royal family. And so it's a compilation of all of the different information that comes into it. You have the anthropology and the DNA and the archaeology and the historical information that all comes together to make an identification. I'm proud to have been involved in this. And I'm proud of all the work that all the people involved in this did. Like, none of us did this in a vacuum, but it was a concerted effort among teams of scientists worldwide to make this happen. If anybody is interested in further reading, there are a number of articles out there. I've included some here. The last one, The Mystery Solved, the identification of the two missing Romanov children, is the handout that I provided. That is open access article put out by PLOS One that also goes through a lot of the information that I told you here today, as well as some of the things that we did in order to make that identification. And so these is my thank you to everyone who was helpful. My passion is working towards the identification of the unknowns, and I was just fortunate enough to have been involved in this particular situation. So if anybody has any questions, feel free to put them in the Q&A.
Thank you very much. That was a really fantastic presentation, and we have a lot of really good comments in the chat. How does DNA help determine the age of people belonging to the bone fragments?
The age of people is not something we did, but you can do that type of testing. There are these pieces at the end of chromosomes called telomeres that break down as you age. And so they'll get shorter and shorter. And so there is some ability to estimate age in that way. Um, how we estimated the age in this particular situation was we used anthropology. And so that was the anthropological analysis to determine the age of the individuals.
When identifying remains of unknown soldiers, how do you begin to identify their relatives, especially if maybe not everyone has done a DNA test or if there's not one to compare?
So each service has what's called a service casualty office, and they keep records of missing soldiers and everyone who should be, who is missing and who is in need of identification. And so they also have records of what is called the primary next of kin. And so when we start doing an investigation into a particular event, we will, that family will be reached out to and asked to donate samples. And so if we're unable to locate a primary next of kin or other family members, if we don't know, we do work with some genealogists who will reach out to, who will find family members for us. And then they take them back to the services, and then the services will reach out to the families. And then it becomes a matter of, people have to be willing to give a sample. But two, we also do outreach around the country. Every month there is a family update meeting in another city. We try to put them all across the United States. So if people want to come and learn more about it, they're welcome to. And if they have a family member who's missing, they should really reach out to their service and see if they can get some information on their family member.
Has there been any speculation as to why they were buried separately?
There was a discussion, there's some historical analysis that they had they were actually attempting to destroy the Tsarina and Alexei separate from everybody else because the bodies themselves were burned and covered in acid to destroy them. They had originally taken Alexei, according to the historical records, there was some notation that they had removed the Alexei and Alexandra to be taken away and kept completely separately. And why they just buried them a very short distance away, there isn't really a clear reasoning behind it. Part of it, the truck broke down. They weren't able to take them any further. But taking out two bodies, I mean, because Alexei was not large, and why they did it in that fashion is really unclear. But they were trying to destroy the bodies so that they couldn't be recognized as martyrs even at the time and be used to raise the population in support of the Russian royal family. So there's no real good reason why they were buried separately.
This person's wondering about the identification of remains in the tomb of the unknown soldier in Washington, D.C.
Sure. We did work and were able to identify the remains of the Vietnam unknown. Um, and the late 1990s. So part of it for the identification of the unknowns, the unknown soldiers, there's a whole process that you go through in order to be deemed the official unknown soldier. And so this started in World War I, where they would take the remains of individuals who were lost, and then they had to be people that they weren't sure who they were. And but the unfortunate thing is that they actually didn't know who most of the people were, which is why we know who Michael J. Blassie is because there were still records as to this is that individual. Because typically what happens is they make a selection of about 10 people who will be going into the grave, and then one person is chosen by committee or by a Medal of Honor winner. When he is buried, all of the records pointing to his identification are typically destroyed. So in this, for Mr. Blassie, when he was identified, the records had not been destroyed. And so we had an idea of who he was. And that based on information from the family encouraged that this be recovered. And we were able to test him and his family member and identify him. So there is hope eventually that this will still be done for the Korea and World War II unknown. However, unless those records are stored somewhere, we're facing kind of an uphill battle on that.
Someone's asking, were the bones of the dog found as well? And curious about how that testing is done for an animal versus a person.
Yes, the bones of the dog were found. And for animals versus people, animals have mitochondrial DNA too, but they have different, the sequence is different enough that that wouldn't work, that the primers and the system that we use wouldn't work on them. So it needs to be a specialized one. There are specialized testing strategies for dogs and cats now. At the time, we didn't have them, but because they're so small, we knew it was known that that was the dog. And yes, they were found. I'm not actually sure where the remains of the dog are buried.
How are the samples of the Romanovs that were used for DNA extraction preserved? Can they be retested if needed in the future?
We returned everything to the Russian Orthodox Church. So because that is actually considered to be a relic, a holy relic, we don't have them anymore. Once they were officially received by the Russian Orthodox Church and by the Russian government, and after we had completed our testing, because they're now buried, the whole family is now buried in a church in St. Petersburg. We returned everything, including all of the DNA we extracted. And so all that has gone back to the church. So at present, no, it's not able to be tested again unless they are willing to exhume them again. And
Okay.
then it could be.
Thank you very much. Thank you for
Welcome.
presenting this evening, and thank you to everyone for attending. And again, if anyone would like a copy of the chat, or if you have additional questions, please send us an email to genealogy@acpl.info. So thank you again, and have a good evening.
Thanks, everybody.
Thank you. Bye-bye.
Bye-bye.